afternoon, everyone. I know we just had lunch break, so some of you might be a little sleepy, so I'll not try to bore you. So the topic of today's discussion is technological interventions in practice. When we speak about technology, it's not just about designing the building or architectural piece, but it's also about delivering the piece, because that's where architecture comes in place. We're not just designing things on paper, but it's about how we execute the final product. That's what we are discussing here. So the subtopic of this is about the technology involved, artificial intelligence, maybe some iterative loops, the scale of projects, and what is being smart. So it's a very big term and a very general term, but let's see if we can cover this. So from our side, I thought that maybe it's better to go through projects which went from concept to execution to show the various iterations of these elements in design and how we dealt with them. So the first project we are presenting is Hilton Kathmandu. So the idea behind this project is, first I'll just take you through what the project is about, because to know someone it's good to know what it is, and then we can speak about the technological aspects and what was done in terms of engineering as well as the design elements. So to begin with, just the background on the project. So as an architect, we have to also look at other aspects of FAR and how we maximize the areas. So in this particular project, we had to use something local to get extra FAR in the project. So what we did was we did a lot of research, but as Symbiosis, we did not want to use wood or this kind of local brickwork. We want to be a bit more contemporary and a fusion architecture. So we looked at these prayer flags of Nepal, which are everywhere, and we transformed this into a dichoric vertical fin. So the idea was to create a very small gesture by using this local element and translating this into architecture of the entire building. Now the site is located in the heart of Nepal. It's in the Naxal area, and from here the highest mountain range which is visible is Lantang range. So as a design response, what we have done is trying to extrude the form, maximizing the views and opening up the top terraces towards the view of the Lantang mountain range which is there. So this is what you see, and the entire form itself was also about efficiency and robustness of the program, to get maximum key count per room and to get views of the surroundings. So this was the initial concept render which was done in the office. So for us it's very important that our concept images and the final images, so the final image should look 10 times better than any concept which we have done. And this is only possible through rigorous engineering and technological innovations which we do. These innovations does not have to be really groundbreaking. At times a very small detail also makes a very big difference in the project. So just to take you through, it's a high-rise project. Also Nepal, Kathmandu is one of the most harsh environments to build for an architect. It's zone 5 earthquake, which means we have to deal with all these earthquake parameters, and the client wanted an immediate occupancy building. Immediate occupancy, if there's an earthquake, there's no damage to structure, internal walls or glass. So glass cannot break, otherwise it's not immediate occupancy. So it's a very clean layout which we tried. Because of the form bending, we have a nice drop-off, lobby, back of house. And then also there's the urban response to the street. So we have a all-day dining, which grab and go, which extends onto the street level. So it's more of a cafe feeling on the ground floor. Typical floor is all about efficiency of the rooms. Then the idea for us was usually all-day dinings, like in this hotel also, 360 is on ground floor. But because you're in Kathmandu, we wanted a person to really enjoy the view of the surroundings. So the last habitable floor is where a person sits, and this is the all-day dining. So if you're in Nepal, you see the views of all the mountains and the valley, not just stuck in ground floor with no view. So you should experience the place where the building is. Then furthermore, going to the terrace, we have a 180, it's a L-shaped pool, which is an infinity pool. Here again, we wanted a person. So this view actually looks at Lantang range. So from here you see the highest mountain range which is visible from Kathmandu. And here again the seating and everything is very relaxed. It was a very chill vibe which we're going for in this project. So this was just getting to know the project, what the project was and how the project is organized. Now in terms of this technological innovations on looking at materiality and trying to execute things. So a large part of the practice focuses on mock-ups. So mock-up is a lifeline of the practice. We do a lot of mock-ups to arrive at a certain aspect of the design. So dichoric glass, around 6 years ago when we started using this, we had shortlisted a couple of things. Short glass was one, but then costing becomes a very big aspect in any architectural project. So that was costing around 300 euros a square feet, which was not possible. So we came up with a dichoric glass, which is a laminate film with a dichoric film in between, laminate glass with a dichoric film. And for this, so dichroic glass effectively is based on the angle of incidence. It reflects a different color. So if you're standing on ground floor and looking up, so you'll see different shades of color on the glass. So these were some mock-ups which were done. So what you see here was a mock-up with the integrated light. And also moving the camera, you see how the glass changes a bit of a color. So this is our interpretation of the prayer flags of Nepal in terms of the facade. This is the same thing during night. So we also want to light up the facade in night, because night lighting is something which I feel is neglected at times. And this really brings the building really up and also activates the skyline of any city which we are speaking about. Then furthermore, the actual form is curved. It's a curve and plan, but we don't want to use curved glass because of issues of costing. If the glass breaks, replacement will be an issue. So this is one of the views which shows this curvature coming in the center. Actually, during concept design, we flattened the glass for all the images. So we ran an algorithm to see the iterations of, and also this glass sizing were coming from the sheet sizes of the manufacturers. We looked at the sheet sizes, and typically there's a glass wastage of 12 to 15%. In this project, we have a glass wastage of only 5%. So we tried to optimize the glass wastage as well as trying to make it planar. So this is just the skin of the glass, and this is to show, so green is all planar glass, and then if it was red or blue, it was convex or concave. So 100% glass in the project is flat. So the idea of technology was in terms of little bit about backend, wherein using computational softwares, we try to simplify the geometry so it becomes easier for people to execute on site. So it's really a back and forth precision. So in precision in construction, again moving forward. So the entire skin is made of these different elements. We have the GRC elements, we have the dichroic glass fins, and we have the glass itself. So these three elements of the facade is what we are looking at. Now coming to GRC, glass maybe I'll cover a bit later, but GRC was very critical because I've heard a lot of people complain that the finishing in curves is never coming good. And the idea for us to use a GRC system in this case was because it's a mold-based system. We can control the mold, we can do digital fabrication of the molds, and the precision we can get is within a precision of plus minus 2 mm. And this is what we're aiming for. This actually shows the repetition of molds. So red is the same mold, here blue, and then we have some non-standard molds which we're using. This is just one of the fabrication drawings which we're looking at just to optimize. For this, we worked out also a special bracket detail in terms of how, so we don't have any spandrel glass in this project. It's a full height glass with a shadow gap. And this is the final GRC panels which were manufactured. So if you see these two panels next to each other, in this case, there was only 2 mm difference between the alignment. And anyway, we need a shadow gap between the GRC for expansion and contraction. Now in terms of seismic, because earthquake zone 5 is one of the most harsh zones to design, given the movement. So for this, we had Miyamoto International doing the structure. They were doing drift analysis and ground acceleration analysis for us. It is a little different because Indian code, so usually Nepal code refers to Indian code for structural guidelines. So in Indian code, zone 5 is defined as complete and utter destruction. So there's no guidelines for zone 5 in Indian code. So that's why we had to change the way we designed this building in zone 5. It was all about acceleration and drift. And based on this, the structure and the facade was also designed. So there's dampers. I don't know if you see in this image, but 32 dampers have been installed, which are like shock absorbers on the lower 4 floors. And then the glass, because it's an immediate occupancy building, glass usually moves horizontally or vertically. So the glass system which we proposed is moving in all these directions to counteract the movement and thrust of earthquake, so the glass is not breaking. Otherwise, 80 to 90% of a building glass will shatter during an earthquake with all the forces it has to encounter. So like I said, I'll try to keep it very short and very fast. So now one of the last parts of this project is articulating the complexity. So this is concept design image, which was done 6 years ago, and this is a built image. So the idea was to get the precision from concept to execution, not just in terms of the materiality, but in terms of the execution and how the alignments are done. So to hang something as complex and as heavy as a GRC, you would remove usually the spandrel panel, go directly into the beam and hang it. But in this case, we did not expose the beam. It's a full height glass. We worked out a special detail for the mullion, and there's only brackets coming out of the mullions on which It's all unitized system. So nothing is being manufactured on the site. It's all factory produced. You just bring, hang, and you go home. So the idea was to really look at this thing of trying to produce things in factory, because in factory everything is much more controlled. If I was making GRC panels on site, maybe the factory manager is not there. They have some, the quality of staff will be lower. How many times? Is it 10 minutes over? Okay. Is it done? Should I stop? Okay. So I'll just run an animation from the second project and then I can stop. So this is Verto, which is an air purification tower. So pollution is a huge issue in the country. And for this, so this is the highest, in terms of cleaning the air, it has the highest potential of 7 lakh cubic meter per day. Since the time is over, I'll just take you to the video and leave it there. Okay. One important thing, this is a quasi 3D printed project. So it's a product which was developed by Studio Symbiosis. And yet 3D printing was used in a way that we are material efficient and trying to be very precise in terms of execution. All these images are final built images. This is because for me actually we like to take images 6 months after a project is finished to see all expansion, everything which happens, to understand what we have done in the project. These are the values. So in terms of efficiency, PM 2.5 we reduced from 127 to 12, PM 10 from 87 to 12. So the efficiency is actually quite good in terms of what we're doing, and just a video to leave it. Thank you.